Hey guys, what's up? This is Swati Sneha and you're welcome to my YouTube channel Big Data Online School. In this video, we are going to learn Hive as a tool. As we have already learned Hadoop, MapReduce, SDFS and Scoop as a tool, and now we are going to learn Hive. In this video, we are going to see what is the scope of Hive, what was the history and how its architecture works. We'll see everything in detail. So let's get started. What actually Hive is? Hive is nothing but it is a tool that helps us writing SQL queries on the top of Hadoop. As you already know that we have two major components of Hadoop, that is nothing but SDFS for storage and MapReduce for processing. So in order to avoid complexity of writing large number of lines codes, in order to write complex codes for MapReduce in Java, we are going to write SQL codes on the top of Hadoop. As you can see on the logo here, it is nothing but it is a bee and the head is of elephant. You can say that elephant top with honeybee body. This means that this honeybee is going to fly over all of the Hadoop components and it will be, we are going to write all of the SQL queries, but it will be on the top of Hadoop only. Let's see all the point one by one. First, we'll go for definition. As a definition, we can say that it is a tool that provides SQL layer on the top of Hadoop. What actually this means? This means that it's like Hive is a data warehouse built on top of Hadoop for providing data query and analysis. Hive gives a SQL-like interface to query data stored in various databases and file systems that integrate with Hadoop to analyze data. Actually, what it is, see, whenever we are using any database, SQL database, we used to write SQL queries, right? But here, if we are going to use Hive, we have to write a query that is called HQL. Hive query language. It is HQL. What do I mean with this? That it is a data warehouse. You can see here, let's say we have a grid kind of structure. Alright. Where we have many number of rows and many number of columns. See, what do I mean with Hive is a data warehouse? It means that Hive looks like a data warehouse which is going to store the data, but actually the storage part is not from Hive. The storage part is from SDFS only. See, whenever somebody sees from the top, what they can see? Let's say I'm the user and I can see from the top what I'll be able to see. I'll be able to see all the grid structure inside that, right? This means that we are understanding that Hive is a data warehouse, but actually where the data is being loaded, it is being loaded into this SDFS only. But the good thing is that it will allow us to write all SQL queries. It will allow us to write all the queries that we BI developers know to write, and we can query on this with the help of SQL queries to get the various analysis purpose data or for something query purpose data like that. So basically what happens is Hive provides an abstraction on the top of SDFS and MapReduce because Hive will store data using this SDFS as I already told, and it will use processing engine as MapReduce. Alright, see, it is showing as an abstraction that it is not allowing user to see the complex MapReduce code behind this or at the back end, but it will ask you or it will allow you to write only that SQL queries that is most similar with that SQL queries, and it will just provide an abstraction on the top of this SDFS so that we can write only SQL queries and it will be processed in the backend as MapReduce or Java queries. So when we write SQL queries in Hive layer, it will convert SQL or HQL query to MapReduce job which runs on the top of SDFS data. This way we don't need to bother about writing MapReduce code in Java for any operation, as Hive will do the conversion from our SQL query to MapReduce code. That's why I'm telling that it's providing an abstraction to users because users can understand SQL query, but as you know that MapReduce cannot understand SQL query, it can understand its Java code. So in order to convert your SQL queries into your Java or MapReduce code, there is a tool called Hive which is going to convert your SQL queries to MapReduce code. Alright. As you know that SQL and HQL have same semantics or you can say the syntax one, so it is not a much of difference or you can say it is almost similar. Also, Hive is fast because it uses a lot of optimization techniques. Next is, let me tell you that Hive is scalable too. What does it mean with scalable part? It means that if the data is going to increase in future, we can increase our nodes or we can increase our data nodes too in future. As we have already seen in our Hadoop part, its property and characteristics part. Let's say if I'm going to expand our nodes from 10 to 100, Hive can also expand its capacity from 10 to 100. Therefore, in nutshell, I can say Hive is a SQL layer where we can write SQL queries which can be converted to MapReduce code by Hive only. Alright, and it is scalable also. Next, we can say as Hive uses MapReduce in background for processing as MapReduce uses mappers and reducers in the background. As I have already discussed here, like how it is going to convert the data in MapReduce. You do not need to bother about that. You just need to understand that you are going to write this SQL code and you will get the whole of the data the same way you used to write in your SQL database. This way, I hope that you understood what actually Hive is. Next, we'll go for history. As we have already discussed in our previous videos, like how Hive comes. Actually, Hive is originated by Facebook in the year 2007. What actually happens because of that Hive used to be originated from Facebook? Like what was the purpose to introduce Hive? As you know that Hive provides a SQL layer on the top of Hadoop that abstracts the complexity of writing MapReduce code on the top of HDFS. Since Hadoop was introduced in 2006 only by dog cutting and then being taken by Apache Software Foundation, then at that time what happened was Facebook had more number of SQL developers in their organization. So proceeded with creating a tool called Hive that will provide a SQL layer on the top of HDFS so that their SQL developer can write their SQL code and it can get the data of all the Hadoop storage data and it will get the processing from MapReduce engine only. Employees from AbbVie can use tool of Hive or HQL that in turn write MapReduce code in background automatically. Let's say I write a query called select count of one from employee. See, let's say I'm going to write from a table called EMP table. Okay, if I execute this, what happens is automatically it writes 100 lines of code in Java in background in MapReduce. You don't need to bother about this. You just need to open Hive and you just need to write this query and execute it. What automatically it will do, it will write hundreds or thousands of lines of code in Java in background in MapReduce to produce the result because MapReduce can only understand Java code only. But here, as you see, we have written that SQL code, right? So this way it is going to work. And let me tell you one thing. Some of the IT engineers understand that if they don't know Java, they won't be able to learn big data tools. Let me tell you, it's a myth. Even I am not from Java background, but I have learned big data tools, right? It's because we have certain tools, we have certain technologies that allow us to write code even if we don't know Java. Alright, so Hive is one of the tools which allow us to write code in SQL language and it will convert everything automatically in the back end and it will run its MapReduce engines that mapper and reducers in the background and it will show us the result whatever we want to know. Next we'll go for HQL versus SQL. As you know that HQL is nothing but Hive query language and SQL is nothing but structured query language. What actually basic difference between this is HQL versus SQL. So basically what happens is SQL, that is structured query language, is a closed environment wherein a database engine SQL is written on top of it. Alright, once we write SQL code, what it will do, it will be converted into diagram code that we don't need to understand, like we don't need to bother about that, and then it will be submitted to its database engine and we'll get our result. Alright, but on the other hand, what HQL is an open architecture tool and it gives transparency to submit the job in MapReduce and produce the result using SDFS. This means that we are going to write the same kind of query, same semantic, same syntax structure as we were writing in our SQL, but it gives us transparency to submit the job in MapReduce and produce the result using SDFS. Therefore, in nutshell, we can say that this database has that SQL database has closed architecture, but Hive has an open architecture. Alright. Also, like Hive performs ELT operations. As you know that, see, Hive performs ELT. ELT means extract, then load, and then transform. But SQL performs ETL operations. It means extract, then transform, and then load operation. So what basically means with ETL and ELT, or what is the difference between that? Since Hive has an advantage because of flexibility, alright, whereas SQL has performance advantage. That doesn't mean that Hive is not good at performance. See, what happens is, what actually it means that if we want much flexibility, we can use Hive as a database. Example, let's say, if I can store any type of or kind of data type in our Hive that comes under. Example is like I can store any kind of data, it may be structured or semi-structured data of any kind of data type in my Hive that comes under the structured or semi-structured format. I'll not be bothered about type of data type of data. First of all, I'll just extract and load it into our SDFS, and then I'll transform it as per the business requirement. Alright, why? Because this SQL is nothing but ELT. See, what actually I mean is ELT and other one is ETL. See, what happens is ELT means it will first extract the information and load it into our tables. Whenever it is required for any business purpose, then it will do transformation. So it will not be bothered about your wrong data type or maybe some different kind of data type. But in the other hand, if you are going for SQL, that is, it handles ETL operation, extract, then transform, and then load. This means that after extracting the data, it has to be transformed. It will be bothered about your data type. It will be bothered about all of the type. Even if it find any micro error also, it will just throw error and it will stop processing or it will fail your operation, right? But on the other hand, if with this Hive, we are going to perform ELT operation, which is going to store any kind of data type in your system. It won't be throwing error or anything. Alright. Next is Hive is flexible. Why? Because it can store any kind of data type and it will not show any error till it is going to transform the data, right? Because it will first load and then it is going to transform. But for our SQL, it is going to transform and then it is going to load the data. Next difference we can see for SQL and HQL is SQL focus on performance much. See, HQL is flexible. Why? Because it is using ELT operation, but SQL is using ETL operation. So it focuses on performance much, as it will not allow anything but only authentic set of data only. But in other hand, if we can see in Hive, we can insert data like anything blindly and it will not throw any error while loading. So this way we can say that SQL is good in performance, but HQL is very flexible, we can say that. Next is Hive is very good in performing high latency operations, whereas SQL it performs low latency operations. Now what do I mean with latency? Latency is nothing but its response time it takes to show output of the data. Let's say we have 1000 records, okay. So to process 1000 record, SQL will take time that is less than 1 second to show the output, whereas Hive will take around a minute, 1 minute to perform operation in that 1000 records. So here you can see the latency. The response time of SQL is obviously much more faster and much more low than compared to Hive. But on the other hand, if we go for throughput, that is nothing but the maximum amount of data that can be used within certain period. Hive performs high throughput operation, but SQL doesn't have that high throughput. Means Hive is good for high throughput. Let's say instead of using 1000 records, if we have 1 million or 1 billion records, Hive will still take time around 1.5 minutes or 1.3 minutes on processing. But as you had seen that SQL was taking time for 1000 records to process as maybe 1 second or 2 seconds. Now this SQL regular database will give output by taking more than few minutes. You can say 2-3 minutes. So here you can see that SQL is not good in handling high throughput data, but SQL is good in handling high throughput data. Alright, therefore we can say that a regular database is not good for high throughput as Hive is. Next difference we can see is no transformation or cleansing needed to load the data in Hive. As we have already seen that Hive is ELT operation, so we are not going to perform any transformation first before loading only. First we need to load the data. Alright, so we are saying that no transformation or cleansing needed to load the data in Hive. because as we discussed that Hive will not mind loading any kind of data type in SDFS. Example, let's say we have a column that has date and that needs to be loaded in our database and the format is wrong for that column. Let's say instead of date we are writing hi, hello, anything inside that. If it is going to be processed in database SQL, like SQL database, it will throw an error and process will fail stating some error message, right? Therefore, we need to clean or reformat the data prior to sending in database. Alright. But on the other hand, if you are going for the same data in Hive, it will not bother about the data type. Instead, it will load the data as null. It will not fail. It will just load your data as null. This way you can see that how flexible or how cleansing is not needed in SQL, but it should be there for SQL. Next difference you can see for SQL and SQL is like Hive perform a query time parsing because of that ELT operation. See, what happens is if we are going to perform this ELT operation and first we'll do extract and then load, and at the time of query parsing we are going to check whether the data is good or not, whether the data type was great or not, anything. Okay. But this ETL performs query. ETL perform a query at the time of data loading only. Alright, that is when the data is loaded, it will parse the data. But here in this Hive, it will not parse the data. Alright, see what I mean is in regular database that handles ETL, it will not parse the data at the time of loading. That is why it is because before loading only, first it will parse the data and then load it. This way, what happens is it will first check the data, validate the data whether it is fine or not, whether it is in the format or not. Then only it will allow for its parsing. But here in the other hand, in Hive, you can see that it is going to perform ELT operation. So it will not check it will not validate your data or anything. It will just load the data and at the time of query, then it will validate and then it will show whatever the structure or whatever the data type is. Next difference you can say is Hive can deal with structured or semi-structured data as well. Semi-structured data like XML data, JSON data, etc. But in SQL, we must be having only structured data to get the data processed. Alright, as we know that we are using our traditional database from since long time, so we are only using structured data format, right? We are not using any kind of XML or JSON data there. But on the other hand, if you are going to use Hive, it can handle semi-structured data as well, like XML file, XML data, JSON data, anything. Next difference you can see is Hive can be easily scalable, as we have discussed in our first part only, because as we know that Hadoop is scalable, so Hive too is scalable since it uses main component of Hadoop only, that is SDFS and MapReduce. Whereas in database, if I want to scale from 10 node to 1000 nodes, it is really difficult to scale that number of nodes. Alright, so let me write here the difference so that you can understand. Alright, here you can see as the difference between SQL and SQL. First of all, the high latency. SQL has high latency and SQL has lower latency. This means that if we fire any query, the response time for SQL is very low in compared to SQL. So it will give your output in very less time, maybe within a second or maybe within few seconds. But on the other hand, SQL's latency is very high, so it will take little time because it is going to process its data with the help of MapReduce, which is nothing but a batch operating system. Alright. Next is high throughput. As we have already discussed, it is very good in handling high volume of data in compared to SQL. If you are going to use SQL, it will handle a high throughput of data. Next, it is flexible. As you know that it is going to operate as ELT. So it is very flexible because it is not going to first of all transform and then load the data. And on the other hand, SQL is very good at performance. Why? Because it is going to perform ETL operation. First of all, it will extract and then transform and then load the data. Next is query time parsing. Query time parsing means that the flexibility only from here also. It means that if you are going to perform ELT operation, it will just extract and load the data, and whenever it wants to extract the data or whenever it wants to remove unwanted data, it will do that at query time only. But for this SQL, it will do everything at the load time only. Why? Because it has to transform before loading only. Alright, so while loading it will just do parsing thing. Next is it will handle structured and semi-structured data, but SQL is going to handle only structured data as we were doing from last few years. Next is Hive is scalable, but on the other hand, SQL is very difficult to like, scale up, and we cannot increase number of nodes here much. Alright, next we were going to see scope. What actually scope is? I mean that I will tell you here like when we should go for Hive and when we must avoid using Hive. So first of all, I'll go what when we should go for Hive or when should I choose Hive. First of all, it's like for the structured or semi-structured data of large size, we should go for a Hive. Why? Because Hive can handle structured as well as semi-structured data. If we have a large set of data, then we must go for Hive. And on the other hand, if we have small set of data, then we should not go for Hive. We should go for only and only our regular database. Next should be like for OLAP analysis, which is not going to write any random operation. That means I'll not allow or modify data, only I'll do OLAP analysis. I'm not going to write anything randomly, but I'm going to do analysis on historical data, that is online analytical processing data. Alright, for that we can go for Hive. Next is if you want to perform schema on read rather than schema on write, alright, then we can go for this Hive. Why? Because we want to perform a raw data analysis. As you already seen that it is going to have ELT operation. So we'll have all the raw data in our table in our LTFS only. Alright, and we can perform any raw data analysis with the help of Hive. Next, why we should go for Hive is if you want to reduce the complexity of writing distributed programming. This means that even if you don't know Java or how to write code in MapReduce, you can write your query in SQL as we already know, as we all of us know how to write query in SQL. So it will reduce the complexity of writing distributed programming. And this Hive is a tool which is going automatically to convert your SQL queries into MapReduce code. So these are the ways or these are the methods where we should go for using Hive. Now the next part is when should we not go for Hive. There are many scenarios where we should avoid using Hive. The first and foremost part is if the data is unstructured format. If the data is unstructured format, Hive cannot be able to handle those unstructured data formats, so we should avoid using Hive there. Next is if you are doing any OLTP operation on small data sets, then instead of going for Hive, we should go for SQL. Why? Because for any online transactional processing or any day-to-day transaction, we should not go for Hive because it's a batch operating system and it will take a high latency as we have already discussed. So instead of going for Hive, we can go for our normal SQL database. Next is it is not suitable tool to perform real-time or interactive operations. It means that you are not able to perform any streaming set of data. You are not able to perform any interactive set of data with the help of this Hive. Streaming set of data, I mean that any streaming set like you generally watch cricket in any of like Hotstar or any of the other applications. Those are streaming part, right? So we are not able to perform those things with the help of Hive. For that, we have some other tools in Big Data that we are going to see very soon in our future. Alright, so these are the scopes like whenever should we go for Hive, whenever should we avoid using Hive. Hope you guys understood that. In our next video, we are going to see Hive architecture, Hive in detail, and many other things like what are the components there in Hive. Till then, bye.